Hi, this is Math 1650, and this video is over Chapter 6, Section 6.1, and we will be looking at the normal distribution, but we're going to start out kind of discussing what's called a uniform distribution before we get to that. First thing I want to mention is we go back a little bit to Chapter 5. In Chapter 5, the sum of all the probabilities for a probability distribution or binomial distribution was equal to 1. And all the probabilities were between 0 and 1. And those two things are going to still kind of hold true for these next distributions. The main thing that's going to be different is for the discrete probability distribution, x had to be countable or finite. Okay, that's not going to be the same thing with the continuous probability distribution. You think of it as a density function. It's all based on how much you have in a certain region. Right. The two requirements here is first total area under a curve equals 1, and the area basically is synonymous with probability. And then the second thing is every probability, let me put that a little bit more together, probability on the curve is greater than or equal to 0, and you can also say it's going to be less than or equal to 1. Alright, so we're going to start with what's called a uniform distribution. This is when every possible value has the same chance of happening. Now we're going to look at it just through rolling a dice. So there's 6 different chances. You can get a 1, a 2, a 3, a 4, a 5, or a 6. And your probability then to roll a 1 is 1/6. Roll a 2 is 1/6. To roll a 3 is 1/6. Roll a 4, roll a 5, and roll a 6 are all same probability as 1/6. Okay, that's what makes it uniform. And in this case, with the dice example, you are looking at more of a discrete probability. But we can look at the idea of this with area. The area underneath this line is equal to 1. All of this has to equal 1. And we can find this if we take the fact that we have 6 possible values and we're multiplying each by 1/6, we get it equal to 1. Okay. But what if we're only looking at a section of this? So what if we're looking at probability of rolling a 2 or a 3? Well, now we're only looking at this section. Right? And for this, you have still the 1/6, but you have 2 values here. So you have 2 on here and 1/6 on your y, and so your area is going to be 1/6 times 2, which is 2/6 or 1/3. And so your probability of 2 or 3 is 1/3. 1/3 of the area under that curve. Now, the reason that's more discrete is you can't roll anywhere in between. You can't roll a 1.5 or 1.6. But let's look at one that is now continuous. Subway times you have to wait between subway departures has a schedule, and the arrival of a passenger are uniformly distributed between 0 and 1 minutes. Find the probability that a randomly selected passenger has a waiting time less than 2.75 minutes. So in this, you're going to wait somewhere between 0 and 5. It could be 30 seconds, it could be 45 seconds, it could be 3 minutes. That's what makes it continuous. The area of the whole box here, it's going to be between 0 and 1. So the area of the whole rectangle box is equal to 1. And we're going to just kind of draw it here. Oops. So we have a rectangle box, area inside equals 1. That means that this is 0, this is 5, so you have 5 on your horizontal. So this has to be 1/5 on the y. Okay, so your probability per minute is 1 over 5. Okay, so but now we want to look and see what's the area of less than 2.75 minutes. So, you know, that's just above halfway, so maybe about here. So this is 2.75, and this is still 1/5. So 2.75 times 1/5, and we get 0.55 or 55%. I can put the 55% down here. Okay. And so that's how we're finding the probability. This with continuous, you're going to see it's going to be either the probability of less than a value or greater than a value, or we'll get into probability between two different values. So if we want the probability of wait time higher than 2.75 minutes, well, it's just the opposite. Then if that is 2.75, this is 2.25. Again, times 1/5, you end up with 0.45. Okay. So now we're going to get in the standard normal distribution. We're not going to have the ability to just look at a rectangle with this, but we will have a computer software that helps us. Now there's going to be standard normal distribution and then a normal distribution. The standard normal distribution has a mean of 0, standard deviation of 1. Okay. The area under the curve is defined as the probability. Total area equals 1 or 100% probability. Now, if you remember back in section 3.3, we looked at a z-score. The z-score formula is x, or z equals x minus x mean over the standard deviation. And it's defined as the number of standard deviations away from the mean. This is the distance along the x-axis. So a graph is going to have a bell curve. The z-score is going to be on the horizontal. Area under this is equal to 1. And what we want to know, well, the probability, we can say this too, the probability is equal to, put this way, probability of area is equal to 100%. We want to know, though, what is the probability of, let's say, x less than 1.23. We'll look at this line, and we'll look at this area less than that. Right. We're going to do this on StatDisk. Now, your homework will have a table that you can use. The table is kind of like really old school. There's also ways of doing this in graphing calculators, and there's other programs like Excel can do this, but it's much more complicated. Graphing calculators can do this, but it's also more complicated. we're going to use StatDisk. It's going to be the easiest way to do it. So probability of x less than 1.23. That again is to the right of the mean. The mean is 0, 1.23. Now remember, for your z-score, our mean in these standard deviations are 0, standard deviations are 1. Okay, right now that's all we're going with. We'll be eventually changing the mean and the standard deviation later, but right now mean is 0, standard deviation is 1. So x minus 0 over 1 means z equals x. Okay, so when we want x less than 1.23, we're actually looking for the probability of z less than 1.23. Okay, so let's get into StatDisk. We're going to go to Analysis, Probability Distribution, Normal Distribution. So Analysis, Probability Distribution, Normal Distribution. And then it should come up. You'll see, and I'm going to actually now shrink this some. You'll see a z value where, let me do it this way. I won't be able to see that. Okay, you'll see a z value. You put a value in for that. You'll see a cumulative area from the left. We could put a value in for this. Now we can only do one or the other, so we can't do 5 and 0.5. It's going to throw up an error. Okay, but we can do 1.23, and we're going to evaluate, and we're going to see that with a z-score of 1.23, we have an area to the left, 0.89065. Right, so probability of z less than 1.23 is equal to 0.89065. That's the area to the left. We are looking for the area to the left, since we are looking for less than 1.23. So this is a probability of 89.1%. And is the probability of x less than 1.23. Now, what if we wanted the probability of greater than 1.23? We are looking at the area to the right. We can come back here, and it gives us the area to the right. This is going to be, again, probability of z greater than 1.23, because z equals x here, and it's going to be equal to 0.10935, or 10.9%. That's the gist of finding these probabilities based on a z-score. Now, the harder one is finding the area in between. So you're going to have to find two areas here. First, we're going to want the area less than 1.23. Okay, we already know what that is. And that's going to be equal to 0.89065. So we know what that is. So we have basically this whole area here because of that. Now we want the probability of z less than -1. Now I'm saying less than -1 because we want this area here that we're going to basically subtract off. All right, so let's put in -1. Evaluate. We take the area to the left. 0.15866. And again, what we're doing is we take the area to the left of the higher z value, and we're subtracting off the area to the left of the lower z value. And we're subtracting off this area to get the area between. So when we subtract these, we'll get 0.73199. Okay, so the probability of z between -1 and 1.23 is equal to 73.2%. Okay. Now, let's say we want to go the other way. Let's say we want to find the z-score. So we want to know the z-score for a percentile of 90. So this is 90%. It's to the left. Okay, so our area to left equals 0.9. So we plug that in. Now plug it into the area to the left. It's going to give us the area to the left again, that's 0.9. Area to the right is 0.1. And the one we want is the z-score is 1.28155. Alright. So let's go through some more examples with this. Again, we're finding the probabilities for a standard normal distribution. Mean is 0, standard deviation is 1. Okay, so with the mean is 0 and standard deviation at 1, z equals x. Alright, so we want to find the probability of a z-score less than 1.25. This is about 1.25, and we're finding the left region. And we go to stat this, plug it in. And we get 89.4. I'll put a decimal first, 89435. So it's 89.4%. Probability of z-score greater than 0.85. Probability of z greater than 0.85. This is 0.85. We are looking above, so greater than, so that's the area to the right. Alright, so we want the area to the right. Right, so 0.85. Area to the right is 0.19766, or 19.8%. Now, the last one, we want probability of a z-score between -1.5 and 0.35. So we gotta do this twice. And we want both to the left. We always take both to the left. You can do both to the right, but this is easier for me to do it both to the left. So z less than negative 1.5. Actually, let's do the higher one first. That way, when we subtract down. And probability of z less than negative 1.5. Okay, let's get those numbers. .35, and we get 0.63683, negative 1.5, and we get 0.06681. So when we subtract, we'll get 0.57002. I don't like how that's written. We're subtracting the two. Let's do that. Subtract. And so we have about 57%. And that is this area in between. Alright. So let's go in reverse. Let's say we want a z-score with the area of 0.4321 to the left. So 0.4321 is this region here. So we're going to put our area to the left equal to 0.4321. So get rid of anything in the z-score, 0.4321. And we get a z-score, z equaling negative 0.17103. In the next one, we want an z-score with an area of 0.3675 to the right. So that's this side. This is 0.3675. So we always have to find the area to the left, because that's how you have to insert it into your stat disk. So we do 1 minus 0.3675, and we get 0.6325. Now we can put that in. And we get a z-score of 0.33848. Alright. Let's do a couple examples that are more applicable. Bone mineral density tests can be helpful in identifying the presence of osteoporosis. The result of the test is commonly measured as a z-score, which has a normal distribution with a mean of 0 and standard deviation of 1. That makes it the standard normal distribution. Alright, and so a randomly selected adult undergoes a bone density test. Find the probability that of someone having a bone density test of less than 1.86. So 1.86 is on the positive side. We want less than that, so we want the area to the left. Right. So z equals 1.86. Probability of z being less than 1.86 equals 0.96856, or 96.9% chance. how could we find the probability of bone density greater than that value? Well, we already done that, and it's to the right. And so probability of z greater than 1.86 is going to be equal to 0.03144 or 3.1%. And then lastly, the probability of having bone density between -1 and 2.5. So -1, oh, -2.5 is a lower value, -2.5 to -1. So we're looking at this small region. So we want the probability of z less than -1, the probability of z less than -2.5. So less than -1 gives 0.15866, less than 2.5 gives 0.00621. And when we subtract, we end up with 0.15245 or 15.2%. Another example, a company uses a standardized test to evaluate employee performance across various departments. The performance scores are standardized, meaning that they follow a standard normal distribution with a mean of 0, standard deviation of 1. The HR department wants to know how well their top performers are doing relative to the rest of the company. What is the probability that employees' performance score is greater than 1.5? So we are looking at probability of x greater than 1.5 because this is a standard normal distribution, z equals x. So this is the probability of z greater than 1.5. And greater than 1.5 means that we want this to the right. So let me draw the graph. Greater than 1.5 is this region to the right. So 1.5. And to the right is 0.6681. Probability of z greater than 1.5 is equal to 0.06681 or 6.7%. Alright, so that is the standard normal distribution. In the next video, we will be looking at what happens when our mean is not 0 and our standard deviation is not 1. And one of the things you're going to find out is most of it's going to be done the exact same way, especially at the very end of it all. Alright, I'll see you in the next video. Bye.